Good morning, good afternoon, or good evening. In this video, we are covering 1.11 lines. So we're going to take a look at the idea of slope, and we're going to take a look at how to graph a line, and we're going to look at how to write the equation of a line, and we're going to take a look at also parallel and perpendicular lines. Okay, so let's start off with slope. Okay, so 1.11 lines. Okay, so we are starting off with the idea of slope. So maybe some of you guys have some sort of an idea of slope. So what are some of the things you think of when you hear the word slope? Okay, so maybe some of you guys said you think of rise over run. Okay. Maybe you guys think of a formula. So maybe you think of this formula, y2 minus y1, the change in y over the change in x. That's a possibility too. Okay. All right. So you are expected to be able to find the slope given the graph, 2 points, and an equation. Okay, so be able to find slope given any of these three things. So if you're given a graph, be able to find the slope. If you're given 2 points, be able to find the slope. And also if you are given just an equation, a linear equation. Okay, so we'll take a look at an example of each of these and how you find the slope. Okay, so example 1, where you're given a graph. Okay, so I'm going to go ahead and draw the graph of a line here. All right, and let me just put some tick marks here so you can keep track. All right, suppose that I have a point right over here. That's at -3, 2. And then suppose that I also have a point over here to -1. Okay. And so that I have a line that goes through these 2 points. Okay. So if you're given a line, the graph of a line, then you're expected to be able to find the slope. Okay, so we're going to use the idea that slope is rise over run. Okay, and keep in mind here, so let's put a little note on the side. Keep in mind that if you have a little person, okay, and they are walking in that direction, right? So to the right. If suddenly the road starts to do this, then you would say that this has what kind of a slope? Positive. Okay. So if you see a line that is rising from left to right, then it would have a positive slope. Now, suppose that the little guy keeps on walking, and then all of a sudden the road starts to do this. Okay. Then here, it would have a negative slope. Okay. And then what if the line starts to do this? The road starts to flatten out like that. Then he's not going uphill, he's not going downhill. So there is zero slope. Okay. And then what if the road suddenly starts to do this? Okay. Then here, in this case, the slope would be undefined. Okay. So let me write that up here. Undefined. Okay. All right. So going back to our graph over here on the left side of the screen. So this would have what kind of a slope? Positive, negative, zero, undefined. Okay. Good. You should have said negative. So our slope is going to be negative. And then what we want to do is we want to count the rise over the run. Okay. So between these 2 points, we want to see, oops, I'm a little crooked here. Hold on a second. That bothers me. I'm going to go ahead and erase those. Oops. Now I erase the whole line. Okay. So let me put that back. Okay, so what we're doing here is, let me do this. All right, so we're trying to count how much does it rise between these 2 points. And so we can see here, because this one here, just in case you can't tell where this is at -3, 2. And this one here is at 2, -1. Okay, so if you don't have them placed there, go ahead and place them there. Okay, so here we see that to go from here to here, it rises 1, 1, 2, 3. So this is 3. And then it runs 1, 2, 3, 4, 5. Okay. So this distance here is 3. So the rise is 3. So I'm going to go ahead and write that down here. And the run, which is this horizontal distance, is 5. So the slope here, you just basically count when you have a graph. You just count the rise, the run, and make sure you also take into account whether it's negative or positive. Okay. So that's if you're given a graph. Okay, so now we'll take a look at, you're not given a graph, but you're given 2 points. So if you're given 2 points, so given a graph, given 2 points. Okay, so if you're given 2 points, like let's say you're given the point -1/2, 2/3, and you're also given the point 3, -2. Okay, so if you're given 2 points, it's not that you have to go and graph these 2 points and then count. You can use the formula that we wrote up above. So here, let's put a little note. That slope is equal to y2 minus y1 over x2 minus x1. Okay. It doesn't matter which one you want to call point 1, which one is point 2. For simplicity's sake, I'm going to go ahead and call this x1 and y1, and I'll call this one x2, y2. Okay. All right, so according to our formula, then we would do y2, which is -2, minus y1. Y1 is 2/3 over x2, which is positive 3, minus x1. x1 is negative 1/2, so I'll use parentheses here. Okay, so let me go ahead and take care of the double negative here in the denominator. So I get negative 2 minus 2/3 all over 3 plus 1/2. Different ways to go about this. If you want to do the negative 2 minus 2/3 and then a 3 plus 1/2 and then treat this like a division, you can. I don't do it that way. What I do is I find the LCD between all four of these numbers. So the LCD between all four of these numbers involved is going to be 6. And what I do is I multiply everything by 6. Okay, so let me show you. And what ends up happening is I do this so that I can cancel out that 3. Okay, and so that I can cancel out that 2. That's why I need the common denominator. Okay, so you can't just multiply the ones that are fractions. You have to multiply everything. So this one over here, this 3, and also this negative 2. Okay, and when you do that, your fractions get cleared. Okay. All right, so what we end up with is negative 12 minus 4 all over 18 plus 3. Okay, so you clear your fractions by multiplying everything, not just the fractions, but everything by the LCD. And then once you clear your fractions, then you should end up with something like this, which is very easy to calculate. So I end up with negative 16 in the numerator and 21 in the denominator. And they don't seem to have anything in common, so you can just leave your answer like that. Okay, so when you're given 2 points, you can use this formula. So make sure, if you don't have it memorized yet, that you memorize that. It's going to be kind of a big deal when you take calculus. All right, so last case, you're given an equation. So example number 3, given an equation. All right, so suppose that you're given this equation here, 3x minus 2y equals 8. Okay, so let's put a little note here on the side. So what happens is when you rewrite an equation like this, a linear equation, so that you have y by itself. So if you get the y by itself and you have the x term on the other side along with the constant, then what happens is when it's written in this form where the y is by itself, then right here, this m, this value next to the x, is your slope. Okay. Does anyone know what this is? So that represents, if you said the y-intercept, then you are correct. Okay. So 0b is the y-intercept. And when we look at graphing later on, we will take a look at this equation, this form when we look at graphing. Okay, so if this means that if we can take this equation that we have here, 3x minus 2y equals 8, and rewrite it so that the y is by itself, then we can identify the slope. So that's how you would find the slope of an equation. Okay, so we find it by rewriting it. Okay, all right, so I'm going to go ahead and let me write it over here. So we want to rewrite it with the y by itself. So I'm going to subtract 3x on both sides. Okay, and that will leave me with negative 2y equals, I'm going to go ahead and write the x term first. 8 and negative 3x cannot combine. They are not like terms. Okay, so it doesn't matter which order you write it in. I prefer to have the x term first. So I'll put negative 3x plus 8. Okay, we don't quite have it solved for y just yet, so we still need to divide both sides by negative 2. So there, and there. Okay, so now we get the y by itself, and this double negative right here becomes positive 3/2 x minus 4. Okay, so when it's written in this form, right? When it's written in this form, then we can tell quite a bit about this equation. We know that the slope is 3/2. So we know it's a positive slope. So we know that it should be rising from left to right. And we also know that the y-intercept is negative 4. Okay, but right now in this example, we're only concerned about finding the slope. Okay, so those are your three examples of finding slope. Okay, so let's just take a look again. All right, so over here, given a graph, you just count rise over run. Given 2 points, you use your formula. And when you're given an equation, you rewrite it in y equals mx plus b form. Okay, so 3 different scenarios, 3 different ways to find slope. All right, so equation of a line. And we're going to look at 3 forms. That last example showed us 2 forms. Okay, so we're going to kind of look at them, and we're going to name them. Okay, so the first one, slope-intercept form. It's called slope-intercept form because you're able to identify the slope and the y-intercept, hence the name slope-intercept form. Okay, and that would be the one that we just looked at where you have it written in this way, y equals mx plus b. And we already saw that when it's written in this form, we can easily identify the slope and we can easily identify the y-intercept. Okay. The second form, you may not be familiar with this one, maybe depending on how you learned how to write the equation of a line. Okay, this one's called point slope. So the first one is slope intercept because you can identify the slope and the intercept. This one here is point slope because you can identify the slope and you can identify a point. Okay, so it looks like this. Y minus y1. So you would have a number there where the y1 is. And then you would have a number here, which would be your slope. Okay. And then you would have x minus x1. And again, you would have a number where that x1 would be. Okay. So here, m would be your slope, and x1, y1 would be your point. Okay. And that's why they call it point slope, because you know a point and you know the slope. All right. The third form is standard form. Okay, standard form, like that last example, that the original problem, the one that we ended up rewriting. So the original problem, that would be an example of standard form, where you have your x term and your y term on the same side, and then you have your constant on the other. Okay. So here, just keep in mind that A, B, and C are integers, so no fractions, no decimals, and also A is positive. Okay, so I'll write that down here. A, B, C are integers, meaning no fractions, no decimals. Okay, are integers, and also A is positive. Greater than 0. Okay. All right. Okay, so what we're doing next is we're going to be looking at how to find the equation of a line that passes through 2 points. Okay, so so we will most likely be using one of these two right here to we use this to write equation of line. Okay, you can use either one of those. Just pay attention to what form they want it in at the very end. So you could use either of those two, but then at the end, it might say, oh, well, write it in slope-intercept form or write it in standard form. So make sure you write it in the correct form at the end, regardless of which method you use to find the equation. Okay, so let's take a look. Find the equation of the line. Find the equation of the line that passes through that passes through that passes through okay, let's do this point, -2, -5, and -7, 5. Okay. And at the end, I want you to write the answer in standard form. Okay, standard form is that last one where the x term and the y term are on the same side. Okay, so the first thing we need is slope. Okay, so whenever you're writing the equation of a line, you always need the slope. Okay, so we need the slope. Do they give a slope? No. Do we know how to find the slope given 2 points? Yes. How do we find the slope given 2 points? We use the formula. Okay, so we're going to use the slope formula, which is y2 minus y1 over x2 minus x1. Okay, so our slope is going to be, again, it doesn't matter which one you call point 1 and point 2. I'm going to call this x1, y1, this one, x2 and y2. Okay. All right. So it's going to be 5 minus negative 5, 5 minus negative 5, all over negative 7 minus negative 2. Okay. All right. So we have those double negatives. So the double negative here in the numerator becomes plus, and same thing down here. Okay. So that becomes 5 plus 5, which is 10. And down below, negative 7 plus 2 is negative 5, in which case our slope is negative 2. Okay. All right. So now that we have our slope, so that's part 1, getting your slope. So now part 2, you do what they're asking you to do, which is write the equation. Okay. All right, so it doesn't matter to me which one you use, the slope-intercept form or point-slope form. I'm going to go ahead and use slope-intercept form, y equals mx plus b. Okay, so you can use this one. All right, and solve for b. Okay, so we're going to go ahead and plug in for y, m, and x. We already know what m is. M is right over here. This is m. So we're going to plug negative 2 in for m. Now, we need to plug in for x and y. So we actually have choices. So we can choose between any of these 2 points. So we can use negative 2, negative 5 for our x and y, or we can use negative 7 and 5 for our x and y. So which one would you guys want to use? Again, it doesn't matter. We'll all get the same answer at the end. Okay. All right. So I believe I somehow magically heard you guys say that you want to use the first point, negative 2, negative 5. So let's go ahead and use that. Okay. So this is going, so our m, we're going to be using negative 2 from down below. Let's pop that back up. So m is negative 2. So we're going to use, for x, we're going to use negative 2 as well from up above. And for y, we are going to use negative 5. Okay. Okay, so let's go ahead and do that. Y is negative 5. M is negative 2. X is negative 2. And we need to solve for b. Okay, so negative 5 equals 4 plus b. Subtract 4 on both sides to solve for b. And we get b equals negative 8. Okay, so long as you have b and m, okay, then you have your equation. So your equation is going to be y equals m x and then plus b, which is minus 8. Okay, so this would be your equation of your line. Okay, now it's a lot of work just to get here, but you always want to make sure that you are done, or to see if they are asking you for something else. Now, when we look at the problem, it says find the equation of a line that passes through these 2 points. So we did that. Now it says this last bit right here, write the answer in standard form. So even though we've already done a lot of work to get here, we are actually not finished because they want us to write this in standard form, which means the x and the y term have to be on the same side. Okay, so standard form. All right, so y equals negative 2x minus 8. So we need to get the x and the y term on the same side. So that means we need to add 2x to both sides. And 2x plus y equals negative 8. All of these are integers. A is positive, so we are now done. Okay, so again, standard form, the numbers have to be integers, and then specifically this one here has to be positive. If it were negative, then you would just multiply everything by negative to turn it into a positive. Okay. All right, so that's how you write the equation of a line. Okay. So now we're going to take a look at graphing lines. And we'll take a look at two methods here, graphing lines. We'll take a look at two methods, one where you make a table of values, and then another one where we use the slope-intercept form. Okay? So when I'm graphing standard form, I like to make a table. Okay. Over here, I'll do example 2. When I'm graphing slope-intercept form, then I like to use that nice little shortcut. Okay. So some people always like to use slope-intercept form, so they take standard form and rewrite it in slope-intercept form, and then they graph it. Doesn't matter to me. Okay. All right. So let's suppose that we have to graph this equation, 3x minus 2y equals 9. Okay, so to me, this is very easy to graph because it's easy to come up with the x and y intercepts. So I'm going to let x be 0. Okay, when I let x be 0, I plug that in. And when I plug that in, I solve for y. Okay, I do it in my head. So if you want to work it out, you can. But again, I do it in my head. Maybe I should work it out so you can see what happens here. Okay, so you choose 0. Okay, you can choose any number, but why would you choose 7.39, right? When you can choose 0. Zeros are very easy, and it allows you to work this out in your head easily. Like if I plug in 0, I get y equals negative 9 halves, okay, which is negative 4.5. I can do that in my head. If I choose x equals 7.39, now I need a calculator. Okay, so let me show you how I got that negative 4 halves. All right, so I plug in 0 for x minus 2y equals 9. That's gone. So I get negative 2y equals 9, and I solve for y and divide both sides by negative 2. Okay. And y equals negative 4.5. Okay, so that's how I get it. Negative 4.5. Okay, I could do the same thing. I can choose 0 for y. That's even easier to do in your head. When I choose 0 for y, then I get 3x equals 9, so x must be 3. Do you guys need me to do that work too? Here, I'll do it really quickly. Y is 0, so I get 3x equals 9. Divide by 3, x equals 3. Okay, so hopefully you can do that in your head. All right, so we get 3. All right, so then you can graph these 2 points, 0, negative 4.5, 1, 2, 3, 4, 5. So negative 4.5 is right around there. Whenever you get fractions, just make sure you're between numbers. I'm not going to break out the tape measure to make sure you're 2/3. or 1/2. Okay. 3, 0, 1, 2, 3. Okay. And so we have a point right there. And then go ahead and draw your line. Okay. So that's one way to do it. Again, this is a lot easier than what it just looked like here because I normally don't show this work. I just do it in my head, which is very easy to do. So when it's in standard form, to me, it's just as easy to find 2 points, the intercepts, as it is to rewrite it and then find in slope intercept form and then find the slope and then the intercept. Okay, so when it's in slope intercept form, so let's look at that. Let's go ahead and graph y equals -3/2 x plus 4. Okay, so something I want to note here about that -3/2. Okay, so whether you have the negative dead center or in the numerator or down below, they all mean the same thing. Okay, it means we're talking about -1.5, not +1.5. Okay, so they all mean that this fraction is a negative fraction. Okay, so if you see it in the middle and you're trying to figure out, oh, well, is that my rise or is that my run? It doesn't matter. Just if you want to pick the rise, always to move it up to the numerator, then that's fine. If you want to choose to move it to the denominator, that's fine. Okay, but you don't have two. You don't have two negatives. Okay. All right. So to keep things simple, let's use this one. Okay. All right. So if my slope is -3/2 and my y-intercept is 0, 4, then it makes it very easy to graph. So you start at the y-intercept, 0, 4. Waiting for my screen. Okay. All right. You start at 0, 4. All right. So we start at 0, 4. 1, 2, 3, 4. Here's the y-intercept, right? And what you do is starting here at your y-intercept, you do your slope, you do your rise and your run. Okay, so our slope is -3. So I'm going to go down 3 from here, from the y-intercept. I'm going to go down 3. 1, 2, 3. Okay, so I'm going down here. Okay, down 3. And then I'm going to run 2. So then I'm going to go to the right 2. Okay. And that's where my second point will go. Okay. And then you can draw your line. And that's it. Okay. All right. Now, had you chosen 3 over -2, you still would have gotten the same line. However, you would have gotten a different second point. So let's take a look on the same line. So if you chose a rise of +3, then from your intercept, you would go up 3. 1, okay, so you would have to go up 3. 1, 2, 3. And then you would have to go back 2. Instead of to the right, you would have to go back 1, 2. And you see, we are still going to be on the same line, whether you make the numerator the negative or the denominator the negative. You'll still have the same line. You'll just have two different points that create that line. Okay? Because remember, those lines have infinitely many points on them, and you just need two. All right, we have some special case lines. They get a little neglected at times. So here, they might get a little neglected because they seem so simple. Okay, but they are often missed on the test. Okay, so the first one is if you have x equals a constant, like x equals 5, okay? And there is no y, right? So the question is, oh, well, how do I graph that? The y is missing, okay? The other case is when you have y equals a constant, some number, like y equals -3, okay? The x is missing. So then students get confused. Oh, how do I graph this if the x is missing, okay? So when you have x equals constant, you're going to have this vertical line because all the x values are the same. They're constant, okay? Here for y equals constant, well, that means your y is never changing. It's not going up, down, it's staying flat, okay? So for example, over here, if you have the equation x equals 3, okay, so if you have x equals 3, then all of your x's are going to be 3. Okay, and so all of the points are going to be like 3, 1, 3, 2, 3, 0, 3, -2. Okay, so what happens is when you graph this, waiting for the rest, 1, 2, 3, 4. Then what happens is right here at 3, at x equals 3, that's where your vertical line is going to be. Okay? And that's all you do. Okay, and then same thing with if you just have the y and no x. So maybe you have like y equals -2. Okay, y equals -2. So that means your y's are not changing. So all the y values of all the points are at -2. Okay, so right here at y equals -2, this is where you would have your line. All right, so those are your two special case lines, the vertical line and the horizontal line. Okay, so let's take a look at this last part, which is parallel and perpendicular lines. Okay, so parallel, perpendicular lines. Okay, all right, so first of all, let's take a look at parallel lines. So remember, parallel lines are lines that never intersect. Okay, so like that. So parallel lines, they have the same slope. Okay, and they have different y-intercepts. Okay. And then if we have perpendicular lines, here, you know what? Let me write down parallel up here. All right, so if you have perpendicular lines, they would look like this. Perpendicular means they intersect, but specifically they intersect at 90 degrees. So don't copy this down. Okay, so if they cross like that, those are not perpendicular because right here, that is not 90 degrees. Okay, so let me erase that. Okay, so they have to cross at a 90-degree angle. All right, so more like this. Okay, 90 degrees right there. Okay, so perpendicular. Okay, so they actually have slopes that are negative reciprocals. Meaning like if one of them has 2/3, the other one would have negative, so opposite sign and flipped. Okay. Waiting. Okay, so that's what that means. All right, so let's take a look and see if we can determine whether these pairs of lines are parallel, perpendicular, or neither. Okay. All right, so determine if parallel, perpendicular, or neither. Okay. All right, suppose that we have this here. So let's look at this set. 3x minus 2y. 3x minus 2y equals 7, and 6y minus 9x equals 2. Okay, so when we look at these, we can't really tell what their slopes are, and so we can't really compare. And when we look at we look at parallel and perpendicular, we know that we can tell if it's parallel or perpendicular by looking at their slopes. So slope plays an important role. Okay, so since the slope plays an important role, we're going to go ahead and rewrite these two equations so that we can identify the slope. Okay, so we need to rewrite them in slope intercept form where the y is by itself. Okay, so let's go ahead and do this. So I have to subtract 3x on both sides. So I get negative 3x plus 7. And then I have to divide both sides by negative 2. So when I divide both sides by negative 2, I get y equals 3 over 2 x minus 7 over 2. Okay, so that first equation, we can see here that its slope is positive 3/2. Now, when I rewrite the second one, if its slope is positive 3/2 and it has a different y-intercept, then they would be parallel. If the slope turns out to be negative 2/3, then these lines would be perpendicular. So let's see what we get. All right, so I have to add 9x to both sides. 6y equals 9x plus 2. And then I have to divide both sides by 6. So when I do that, I get y by itself. 9/6 reduces to 3/2. Plus 2/6 is 1/3. Okay, so we got that because we divided everything by 6. All right, so making the comparison, we see that they both have the same slope, different. You always make sure, because if these turn out to be the same, then they're actually the same line. Okay, and parallel, which means they intersect everywhere. Parallel lines do not intersect, so they cannot even be the same line. Okay, so here we would say that these guys are parallel. Parallel, they both have the same slope, different y-intercept. Okay, let's take a look at this next one. Let's see if we can figure out whether it's parallel, perpendicular, or neither. All right, so 4x plus 2y equals 3, and 3x plus 6y equals 1. Now, at this point of the video, if you want to go ahead and hit pause and try it yourself, and then hit play when you're done to see if you get the same answer, then that's normally what I would do in class. Have you guys try this one on your own, okay? All right, so either hit pause and do it and then come back, or just follow along, okay? All right, so over here, I need to get the y by itself, so I'm going to subtract 4x on both sides. And then now I'm going to divide by 2 on both sides. So y equals negative 2x plus 3/2. Okay, and then down below, I am going to subtract 3x on both sides. And then I'm going to divide both sides by 6. That gets the y by itself. Negative 3/6 is negative 1/2. Okay, and plus 1/6. Okay, so here, so we look at the slopes right here. We almost have perpendicular, and it does not look like we made a mistake. So here, they both are negative, so we know it's not perpendicular. Almost. If one of these were positive and the other one were negative, then yes, we would have perpendicular. But because they are the same sign, they're not perpendicular. Okay, and clearly they're not parallel, because parallel, they have to be exactly the same, and we're not. Okay, so this one here is neither. Okay, so that concludes our lesson on lines. Again, if you have any questions, feel free to text me or email me. All right, enjoy the rest of your day or your evening, whatever it is that you're doing.